Hello everyone, welcome back to my channel Infinity Plus. Today we are going to explore the amazing concept of mathematics, that is linear programming problem. This topic is not only essential for the 12th grade student but also for the students who are doing the BSc and engineering. Linear programming problems is having numerous real world applications. So let's understand what exactly is LPP. Linear programming is a method used to find the optimal solution. So what it is? It is method to find optimal solution for a problem that involves linear objective function subjected to linear equality and inequality constraints. The goal is either to maximize or minimize the objective function while satisfying all the constraints. So consider you are having a problem which is given in the form of a objective function, and here you have to find the optimal solution for this function. Optimal solution means it is either the maximum value or the minimum value for the problem. So this is not only you have to find maximum or minimum. Here they have given some of the constraints. Constraints are nothing but it's obstacles. So you have to find the optimal solution for that objective function subjected to these obstacles or constraints. So let's understand what is objective function, what is optimal solution, and what are constraints in order to solve the sums. Before we start solving the problems, so let's first understand some key basics of linear programming problems. So first we'll understand what is objective functions. Objective function is a linear equation that needs to be either maximized or minimized, like profit or a cost. So objective function, they will give you a linear equation which you have to find either the maximum value for it or you have to find the minimum value for it. And the objective function is denoted by z, which is in the form of ax plus by, where here z is equal to ax plus by. In this, a and b are the constants which they have given in the objective function, and x and y are called as the unknown variables, which is nothing but the decision variables which will help to find the maximum or the minimum value for the objective function. So these x and y, they are called as the decision variables. Next we will understand what are constraints. I have informed you earlier, constraint is nothing but obstacles. So let's understand in mathematical terms. So constraints are either limitations or restrictions. As I have mentioned earlier, it is a obstacles or limitations or restrictions expressed as linear inequalities. It can also be written as ax plus by is less than or equal to, or it can be greater than or equal to c. So constraints are the restrictions expressed in terms of linear inequalities. See, objective function is equality. So we are having the equal symbol, and here the constraint is all about inequalities, where you will be having either less than or equal to or greater than or equal to. And the next one is feasible region. It is a area on the graph which satisfy all the constraints. So the solution for the objective function lies in the feasible region. That's why the feasible region is considered to be as the most important, and it could be a bit confusing in some of the problems. We have to be more careful while solving the sums. So last but not the least, let's understand what are non-negative. So non-negative restrictions are the decision variables x and y which should always be positive, means they should not be negative, and it can be written as x is greater than or equal to 0, means we have taken x and y are the decision variable. So first one is x is greater than or equal to 0, which is positive, and y is also greater than or equal to 0, which is also positive. So these are the few basics which you have understood before solving the sums for the LPP. So let's move on to the most important 6 mark sums. Solution of LPP can be obtained by numerous method. We will be having two such methods such as graphical method and another one is simplex method. But in this video, we are going to understand the most important graphical method. So, we will be solving the problems which are related to first the maximization and second one we will be having one problem related to minimization of the objective solution and third one we will take which is having both the maximization of and the minimization of the objective functions. So let's move ahead with the problem. We will be having it as solve LPP graphically where we have to maximize. So they have given the objective function as z is equal to 4x plus y. I have already given what is objective function. A function which is of the form z is equal to ax plus by. So z is equal to 4x plus y is the objective function subjected to constraint. These are the two constraints they have given. X plus y is less than or equal to 50, 3x plus y is less than or equal to 90. And these two, x greater than or equal to 0 and y greater than equal to 0, they are called as the non-negative constraints. So first write down the given things as it is. So the z is equal to 4x plus y is the objective function I have written as it is with the constraint. First you have to take first constraint. So first constraint is x plus y is less than or equal to 50. Now we have to find the solution for this x plus y is less than or equal to 50. Instead of taking inequality symbol, I will be converting it as in a equality symbol. X plus y is equal to 50 because it is very easy and you have already solved linear equations like this. So give value for x. I am giving x value as 0 and substitute you here what you will get 0 plus y is equal to 50. Then value for y you have got it as 50. Now I am giving y is equal to 0. What you will get? X plus 0 is equal to 50 in this equation. So what you will get? X is equal to 50. See, you might have already solved how to plot a graph. So you have to plot the graph for both the constraint line x plus y is less than or equal to 50 and 3x plus y is less than or equal to 90. So first we are plotting graph for x plus y is less than or equal to 50. So what the table we have got, write it as it is in this. So if x is 0, we have got y as 50 and if y is 0, we have got value of x as 50. So let's solve next constraint. That is 3x plus y. I have converted inequality into equality symbols. Give x is equal to 0. You will get the value of y is equal to 90. If I am giving y is equal to 0, we will get 3x is equal to 90 and x is equal to 30. So we will get points as x and y such that if x is equal to 0, then we will get y as 90 and if we are having y is equal to 0, we will be having x value as 30. Now we have to plot a separate graph for both the lines x plus y is equal to 50 and 3x plus y is equal to 90. So let's understand it in a graph. So let's plot the graph of both the constraint for the following table. So this is the table for the first constraint and this is the table for the second constraint. So we have taken a Cartesian plane having a x-axis and the y-axis. Since we are having 0, 50 and 90, according to these numbers we have to take the scale. So I will be taking each box as 1 centimeter is equal to 10 units. So this is 10, 20, 30, so on. So write up all the numbers. Now let's plot the first line. If we have taken the first line, what you will get? We will be having 0, 50. If you are having 0 on the x-axis, we will be having 50 on the y-axis. So this is the first point. So next point will be 50, 0 and this is 50, 0. So by joining these 2 points, we have got a graph for the line x plus y is less than or equal to 50. Now let's plot the graph for the second constraint. That is x is having 0, and y is having 90. So plot the point 0 comma 90. So 0 on the x-axis and 90 on the y-axis. So this is the point, first point we have got. So next is 30 comma 0. 30 on the x-axis and 0 on the y-axis. So join these 2 points to form another line. So the graph of second constraint, you have got it as 3x plus y is less than or equal to 90. So we have plotted the lines for both the constraints. So now it's a time for your non-negative constraints. So what are non-negative constraints? You will be having x greater than or equal to 0, which will come the upper side of the x-axis, and y greater than or equal to 0, which comes this side of the y-axis. Since for the first constraint we are having x plus y less than or equal to 50, we will be having all the solution which is less than this line. Means you have to take this region which is below this line. If it would have been greater than or equal to 50, it would be the above region for this line. So this is the solution for the first constraint. So for the line 3x plus y less than or equal to 90. So obviously if this is the line, you will be having the solution area as this one. This complete the region which is just below this line. We can find out that this is the region where both the lines or both the constraint meeting each other. So this is called as the feasible region. The coordinates of each point, we will be having it as A as 0 comma 0, which is the origin. B coordinates are 30 comma 0, and C coordinates we can notice from the graph 20 comma 30. So C coordinate is 20 comma 30. Next we will be having the D coordinates, which is 0 comma 50. Now substitute all these points in the objective function to get the maximum value for it. So we have taken a table where we will be having all the points and we are having the value for the objective functions. So point A is 0 comma 0. If we substitute the point A in this objective function, we will get the answer as 0, because both the unknown variables are 0. Now if we substitute B point in the objective function, we will get 4 3s as 120. And if we substitute C point in the objective function, which is 110. Next the last one is, we will be having 0 comma 50. So 4 into 0 will be 0 and we will be having 50. Among these values, which is the maximum value for the objective function which I have got, is the solution for the objective function. So we will be having Z maximum value which is equal to 120 at the point that is B of 30 comma 0. So this is how we have got the maximum value for the objective function in a simplest manner.